Hi, I am Chinyere Charles-Okezie.
And I'm Gladys Alamu.
Today we'll be analyzing the Bieber fever using Simulink. In the model we'll be discussing, two people named Tweedle and Smith used the infectious disease model to model the public's obsession with pop star Justin Bieber, which they tagged the Bieber fever. While observing the Bieber fever, in quotes, they discovered that it had similarities to several infectious diseases in terms of its rapid transmission rate, the eventual recovery from the disease, scarring in terms of tattoos of Justin Bieber's name or face, and the presence of symptoms. In this case, an example of a symptom is the excessive purchasing of merchandise.
So the SRR model is a common model used to investigate contagious diseases such as COVID-19 and the influenza. S represents the population susceptible to infection. I represents population currently infected with the disease or at any time. R represents the population who have recovered. The sample size in this model was individuals aged 5 to 17 within the population. These are the equations that were used in this model, and as stated before, S is the susceptible population, I is the infected population, and R is the recovered population. There are constants in this equation, and the first one is R, which represents the recruitment rate, and it describes the rate at which individuals become susceptible to the infection. Beta represents the infection rate, and it describes the rate at which the Bieber fever is transmitted from one person to the other. B is the boredom rate, and the higher the boredom rate, the higher or the quicker people get bored with Justin Bieber. And in this model, we use 1/24, which is a relatively slow boredom rate. And the last constant is mu, which is the maturation rate, and it describes how people grow out or eventually get tired of Justin Bieber.
This is the graph that was plotted using our Simulink block diagram. From the graph, in our block diagram, we used a boredom rate of 1/24, which is a relatively slow boredom rate. From the graph, we see that there is initially a rapid spread of the Bieber fever because we can see that there's a rapid rise in the infected population. Over time, the infected population begins to shrink. This is because people get bored of Justin Bieber over time, people mature out of Justin Bieber, and people also recover from the Bieber fever, in quote.
And this is a visual representation of the Simulink block diagram that was used.
These are our references, the Tweedle, a mathematical model of Bieber fever, and the differential equations in music and dance from the Journal of Mathematics and the Arts. Thank you. Once again, I am Chinyere Charles-Okezie
and I am Gladys Alamu. Thank you for listening to our presentation.